Alrighty. Okay, this video is specifically for the S500s step D here. In the generic kind of video for the whole assignment, I mentioned there's differences between the S500s and the X500s. Okay, so this video is the S500 portion of step D. Okay, so S500s have an F405 flight controller on board, and that flight controller is I guess we'd say a lower end at this point in the ArduPilot world, and so it doesn't have quite enough CPU, enough processing power to do all the same things that the H7 flight controllers on the X500s can do. So there's a little bit of difference here on how we set these up. Okay. We talked about notch filters in the other video a little bit. We'll talk about them in class too. What we're going to do for the S500s is do a throttle-based notch filter. Okay, so let's click on this page here. Let's close these other ones out. So a throttle-based notch filter basically means there's a notch filter that moves around based on your throttle input. Okay, which is typically, as your throttle moves around, the motors will change speed, which means the vibration changes frequency. Okay. So it works decently well. There's ways you can track the vibration better, but we can't really do that with the F405 flight controllers. Okay, so we're going to do a throttle-based setup here. So this link here, this is on the throttle-based dynamic notch setup page. Okay, if you do not have ESC telemetry, which we do not, unfortunately, have the ability to do that very well with the F405s. Okay, and we can't use the in-flight FFT mode because again, our flight controller can't handle that. Okay, then basically the throttle-based center frequency control is best. Okay. In order to configure the throttle-based notch, we need to make sure we see the motor noise at a hover throttle level. To do this, we need to use the batch sampler to obtain logs for analysis. Okay, that's what we just did in the other explanation. We gathered the data through the batch sampling to analyze. Okay, so we've got that set up. Once this is done, the center frequency of the notch can be set and other parameters configured. Great. So we have the information we need now to configure the notches. Okay, so the throttle-based mode, there's two harmonic notch, I guess, options you can set in ArduPilot. There's, number one and number two. We're not going to use two different notches. We'll just use one most likely. Okay, so all these spots where it says INS HNTCH mode, and then it says HNTC2 mode. This is just the second version of this. We're just going to use the first version, so don't worry about any of these ones that have the two in them. Okay, so INS HNTCH mode, okay, is going to be set to 1. All right, so if we go into Mission Planner and we look at that, let's go to our parameter list. INS HNT, oops. Okay, so INS, I can't say this, HNTCH enable. Okay, so if yours is disabled, which it probably is, you want to enable it. So this here just enables that notch. Okay, once you've enabled it, you'll then see all these other parameters. If yours is disabled, you won't see these other ones related to the harmonic notch because they're not enabled yet. Once you've enabled it and you've written the parameters, okay, then you can do a refresh params, okay, and that will pull down all the other parameters related to the harmonic notch, so you'll see all of these like I see here. Okay, you can see the INS HNTC2 enable is disabled right here, so I don't see any other HNTC2 parameters right now because they're all disabled. Okay, hopefully that makes sense. All right, so once it's enabled, we're going to basically set the mode, okay, to 1. All right, so if we go to Mission Planner here, let's see, where's mode? Here's mode. Okay, so we see 1 equals throttle, 2 is RPM sensor, you see ESC telemetry. So different types of notches can be set. We're going to set ours based on throttle, so we're going to set it as 1. Okay. Then we have a couple different values here we need to adjust. Excuse me. Okay. INS harmonic notch reference equals hover thrust. Okay, so like what is hover thrust? Okay, INS HNTCH frequency equals hover frequency. What's hover frequency, right? Harmonic notch BW for bandwidth. Okay, hover frequency divided by 2. You're like, where do I get these italicized values? Okay, where are those from? Okay, and I'm just going to show you, I have a little slideshow I created for you guys in this assignment to help with this. Okay, so if we go here to the slideshow and we go down here, so it's going through all the steps, vibration, we talked about in the other video and stuff. Okay. All right, so here we go. Okay, this is a screenshot from the page we're looking at. you need the following: a hover thrust value. Okay, hover thrust value is mott thrust hover. Okay, so if you look in your parameters in Mission Planner, we used mott thrust hover when we did altitude hold a little bit. Oops. Let's type mott thrust. There we go. Mott thrust hover. In my case, it's 0.35. I'm actually plugged into a flight controller that's never flown, so it's just on the default. Usually maybe a little bit lower than that. Okay, but that value, okay, is your hover thrust value. So it'd be 0.35 for me. Hover frequency value. This is from our graph earlier. So the pre-filter graph had a frequency of 100 hertz right here. So we see that kind of lines up with 100. Okay, hover frequency divided by 2 is 100 divided by 2 equals 50. Okay, so I have all these values already from the previous steps in this assignment. You just got to know where to find them. Okay, so again, hover thrust is from mott thrust hover. Hover frequency is what you found on the graph, the first big peak going from left to right. Okay, and then you just divide that frequency by 2 to get the bandwidth value. Okay, let's go back over here. So now we have a hover thrust, we have a hover frequency, and hover frequency divided by 2. So you set those up into our parameters here, here, and here. All right. We have a couple other parameters down here. The harmonic notch FM rate, or RAT, I guess you could say. And you basically set this to allow the filter to go below hover throttle a little bit. Okay, if you want. You don't have to set it to go below hover throttle at all. Lower frequency notch filters will have more phase lag and can impact stability. Okay, so if you want the filter to work just at hover throttle and above, which is kind of the default, that's fine. You can just leave it alone. Okay, default value of 1 means the notch will not go below the frequency that you set here. Okay, which in our case was 100 hertz. Right, and that should work just fine. But you can get a little bit of advantage over going a little bit below the hover frequency. And so example here they use is set it to 0.7. It will go up to 30% below 100 hertz. Okay, and that is fairly safe from what I understand. You don't want to go much lower than that because again, the lower you go, there's more lag in the loop. Okay, more phase lag it talks about here, and that can really make the copter unstable to fly because it's creating so much delay in the loop that the copter is operating to try to control itself on data that's already, we'll say, old. It's not currently happening anymore. It's too old to control the copter well. So leaving it at 1 is fine. I would probably just advise you most of you to do that. If you want to play with it a little bit, I wouldn't go too much lower than 0.7 to make sure your copter is still stable. Okay. So this is the setup basically for our throttle-based notch filter. Okay, we have some advanced setup and things like that down here. I wouldn't worry about that. Just this section here is what you want to worry about. Okay, check the performance of the filter by doing another post-filter configuration test as discussed in the batch sampler section. Okay, so again, once you finish, let's get out of this here. Well, let's go back here. There we go. Sorry. Okay, and so the wiki instructions talk about capturing post-filter gyro data. So after you've set the notch, you change it to post-filter, you go fly, and you look at the logs again, and you say, well, the peaks are gone. There we go. It worked, you know. Okay, remember the amplitude scale here. So the filter appears to be working pretty well, and that would be a success, okay? So that's what we do for the S500s, all right? That's the filter part of it. Then you'd have those screenshots like I have here, okay? Pre and post filter, and you'd move on to the auto tune process for your aircraft. Okay? All right, hopefully that helps with the notch filtering for the S500s.